Okay, so last Friday, we discussed. Let me just review the practical way for the integration. Okay, now we mostly review on the fundamental theorem of calculus, and basically the fundamental theorem of calculus we are going to use if we have uh, these integrations, and we are stated this integration using another variable t usually. And basically what the fundamental theorem of calculus say, that if we derive this result is equal to the original function of this uh, small f here. Okay? And basically every continuous function, they all have their own antiderivative. Okay? And how to use the fundamental theorem of calculus, let me go through here. Basically, when we are deriving this g, we take these functions, put on this t squared here, and basically we are going to have this 1 plus x squared. But then, what will happen if we have 2x in the endpoint? The same thing, but if you um, imagine this 2x as u, then aside from putting this 2x into the t squared, we are going to use chain rule to make it this into d over dx, which is 2. So basically, if we have this gx, and gx is integration from 0 to some function x, let's say hx of ft dt, then the g prime, or the first derivative, is the function itself, and then we plug in the h of x, and then we have multiplication of the h prime x. This is because of the chain rule that we have. Okay, now I would like to take some time to review before we are going to enter the substitutions method or integrations. We're going to review and give you some more examples, maybe 2 or 3 examples, so that we can have much more uh, clear and understandable sections on this part. Let me go through. We start with this. So, as I mentioned, that the fundamental theorem of calculus, it's connecting the integrations with the derivative. So all the derivative behavior properties, you still need to use all of them, especially in the chapter 4, when you learn on where the function is increasing, decreasing, concavity, all that, all those information. You still using that, and then you simply having the same question. Okay. For example, we can start from number 72 here. Let's start from 72. We have a function that is stated in the integration from 0 to x, 1 minus t squared, and then e with power of t squared dt. And it's asking on what interval the function is increasing. Okay, probably I will do this for you for number 72 to give you much more clear information. So we have, let me write, we have f of x is integrations. Okay, now increasing is when the first derivative is positive. This means it's increasing, right? Now then, we can derive this. And doing some fundamental theorem of calculus, we put x inside, and x derivative is just 1, so not a problem at all. So we can take this and write down first is that, and second goes here also, and then e with power of x squared. Okay, and then what we can do from here, we need to know that we need to have this inequality, right? So 1 minus x squared, e x squared should be greater than 0. Okay, and then this e, okay, we can say this e is always positive, right? You can state this because e, if you check with the negative 1 squared, still it's e, right? And every numbers that you check, that's resulting e negative, e positive, right? So it's always positive. So we can say that 1 minus x squared or should be greater than 0. So the only way we can know which interval is from this. So we take this, or we say that so we have this, right? So f of x increasing on negative 1, 1. Okay, any questions? Okay, is it clear? I think clear, right? Okay, now we can start 73 or 74, up to you. Which part you want to check? How about okay, 73, okay. 73. On what interval is the curve? This is the curve. This is the curve. On what interval the curve is concave downward? Okay, so now concavity is determined by the second derivative, right? So we have second derivative. So it can be positive, it can be negative. If you have positive, it means it's concave upwards. If negative, it's concave downwards. So we need to find where the second derivative is negative. But more or less, the idea for this question is to derive two times. Okay? First, because it's having integrations, we can do the fundamental theorem of calculus. We are going to exchange t with x. So the y prime is x squared. Okay, that's the first step. Now the second step is a little bit complicated, but still doable, and I think you also still can do the derivative. Okay, you can try. Find the second derivative from here. Now what you can do is you need to use the quotient rule. Okay, so imagine this is f, this is g. For sure, the bottom part, the denominator should having squared, right? And at the top will be 2x, and then x squared plus x plus 2 minus x squared 2x plus 1. And then we can solve this. We can solve. Still the bottom part, and this write as it is. Just write like that. And for this part, I will write here first to make sure that I'm correct. So we can cancel this with this. So we have oh, it should be minus. Minus, so x squared, we have x squared plus 4x. Yeah, this will be our result. But still, we need to check how we are going to have the concave downwards interval. Now, we need to have this to be less than 0, right? And now we need to have our analysis, our observations, and we need to make sure that we understand our subject very well. So first, the bottom part here, do you agree that this is whatever numbers we are using, how large the number is, how negatively large the number is, it's always positive, right? Because it's having a squared. It's having a squared here. So this is always positive. So we can ignore, actually, because we want to find the possibility whether these statements are negative. So we can know that from x plus 4 should be less than 0. Now we have at least negative 4 and 0. If we check with our numbers, if we check negative 5, it's positive, right? It's positive. It's negative 5, it's negative 1. Negative is positive. -1 should be negative, right? Should be negative. It's positive, of course, positive. So we need to know that this is our interval. So concave downwards. When the interval is from -4, 0. When when interval. Okay. I think also easy to understand, right? Okay. Okay. Now, let me check our time. Okay, we still have time. How about this number 74? And I think number 74, you don't need to write any calculation at all. You see the curve. You see the curve. If the functions, this capital F, it means that the capital F is integral of the small f. Or we can say the f is antiderivative of f, right? Of the small f. And the graph is showing you the small f. The graph is showing you the small f. Okay, this f. You need to be careful. Okay, you need to be careful. So again, the question is still the same, asking concave downward, which means we need to take the derivative. Okay, we need to take the derivative. But we need to focus on the capital F. Okay, so take the capital F, f prime. That's the first derivative. This will be equal to f of x. Okay, using the fundamental theorem of calculus. Now concavity, we need to secondly derive this, and this becomes f prime x. So concave downward is when this 0 or f prime x is less 0. Okay. Now do not make any confusion or mix up with the first derivative and the second derivative. We need to state that this is our subject, the big F, the capital F. Because of this less 0, the second derivative of capital F is less 0, then the first derivative of small f is less 0. Okay. Now we can know this from this f. What the first derivative means, it means that the slope decrease, right? Okay. So the only way the slope decreasing is this one. Okay. Got it? So f, the big F, concave downward when interval is -1, 1. Yeah, that's it. Any questions? Any questions? Okay. If there's no questions, let me move on through the next one. Do you still need to write the notes here? Okay, well, I will move to the next page. Okay. Okay, let me check whether I've prepared another questions or no. Let me check here. Oh yeah, maybe try this one. Give you a couple minutes to try. Okay, anyone got the answer? Okay. Okay, do you get the answer for this question? What's the answer? Yeah, you can write the answer if you finish on the chat box. Yes, correct. 29. So perhaps this is important for you. So if we have this is the I think also last week problem. We can state this as, and this is the net change theorem, right? It's in the net change theorem. So basically, if I have 1 to 4 f prime x dx, forget the dx. So this is f4 minus f1. So f4 is plus f1, or based on our calculation from the given information, this is 17 plus 12, 29. I think this is not so difficult, right? So maybe one more questions, okay? Another typical questions for the fundamental theorem of calculus is if we have this limit, okay, this limit, and it's having the integration. So basically, all the part one of the calculus, which is chapter about limit to application of derivative, we are still going to observe in the integrations. Okay? And basically you need to at least you need to remember the concept, okay, for this part 2. And now it's part 2 about the integrals. Now if you have this, okay, I'll be showing you just the first step. Okay, so maybe we just this uh, just this limit here. Okay, this is, you can try this on your own. Okay, now the right one here, we have limit uh, integration from 0 to x ln 1 plus e to the t over x squared. Now first, before we trying something on this limit, we can try to rewrite this in more clear way that stated and clearly show the numerator and the denominator. Okay. Now, if you remember how we can take the L'Hopital rule, if we check when x is going to have an infinity, then we will have infinite over infinite, right? Infinite over infinite. So we can take this, or we can write here infinite over infinite, and then we can take the L'Hopital rule. So we can take the L'Hopital rule and derive each numerator and denominator. So derive, this will be 2x, and the top one is just ln 1 plus e to the x. And we are going to check once more, it's still L'Hopital. We take the second L'Hopital, and we can write this. This become 2, and this become 1 over 1 plus e to the x, multiply with e to the x because of the chain rule. We can solve this first, simplify the equation. And now we can divide, I think we can divide with 1 over e to the x, 1 over e to the x. So we can write, this is become 1. This is 2 plus 2 over e to the x, and then 2 this part becomes 0, right, because of the limit. So it will be equal to 1 over 2. Now you can do the same thing for the left one, and I think you can do it on your own. Okay, so you can do the L'Hopital rule. Okay, now I think we can move on to know more about the substitutions method in the integration. Now let me go through directly. We'll be going to the new page. Okay, let me give you an integrations. X over square root of 1 plus x squared dx. Now in substitution method, as we mentioned, we need to take or exchange some part of the element on the integrations into another variable, and we call it variable is called u variable. Well, it can be any variable, but usually we are writing in terms of u. So we are going to have u equal to. Now it depends on your preference which part that you are going to use, because sometimes it can be more than one possibility. So for example, I can start this u variable with 1 plus x squared. Okay, I can start with this. Why? Because when we derive becomes du, this will be 2x dx, right? And then if we change in terms of dx, this will become 1 over 2x du. So what is the idea of the main idea of the substitution? The main idea is from all these elements, we need to exchange the variable x or any elements of that into another variable. And when we change the derivative of that variable, they need to cancel one of the element in the integration. For example, we have this now, our dx is 1 over 2x. If we exchange the dx, this will cancel this x, right? Now that's the main idea. So if we take this and we can write it's become 1 over square root of u, and dx is, let me write x over 2x du, right? And we can cancel this, so we can write, and we can factorize half outside because of the constant, and this is just integration of 1 over square root of u, or we can write in terms of u negative half du. Now we can solve the integrations. So u can plus 1, and then this will be also or this is half. So half and half will be cancelled. So this will be cancelled. So the result will be u with power of half, or we can write 1 plus x squared with power of half plus c, or square root of 1 plus x squared plus c. Okay, this is the first possible u. So remember, the idea to change the x into variable u is when you derive, you need to make sure that the result of that derivative can cancel one of the element in the integrations. That's the main idea. If not, then you will have two variables inside one integration, and it's not have any conclusions if you have two variables inside the one integration. So this is first possible method. The second one, I'm going to use different element of this question. It's the same question, but I will use different element. So let's say we have u. I will just use all square root like this. But before I derive, let me take square both sides. So we have u squared equal 1 plus x squared. Okay, clear? Now I will take the derivative from both this or let's just say we derive both of this. This become 2u du and this become 2x dx. We can cancel that part. So dx will be u over x du. I think this is correct. Still okay. Still possible, because when we have u over x, we can cancel the x, right? And then all the variable x changing to variable u. Okay, now we can exchange and write down the integrations. Let me write all the integrations. This become u, okay, the square root of 1 plus x squared, and dx will be u over x du. So it would be cancel, and so it's just integration of du, which means this is going to have u, right? The integral of the u is u. So u is square root of 1 plus x squared and then plus c. Same answer. Okay, is it clear? Is it clear for everyone? Okay. Okay. So basically, from one integrations, you can have many possibility of substitutions. It doesn't always like you have only one possibility, but you can choose. Okay, you can choose which part that you are going to substitute. Okay, which part you are going to substitute, and you need to make sure when you derive that part, you can cancel the other part. That's the idea. Okay, so first possible method, second possible method. Now I will show you the third one. The third one. Now it's called the advanced guessing. So let me write the question. Okay. Now the idea behind of this is we need to know the derivative of some functions that essentially easy to derive. Okay. For example, if you have a functions that have square root, okay. For example, functions like square root of x, okay. If we derive this will turn out to be 1 over 2 square root of x, right? Okay. And if you have, for example, 2x, for example, this will be 2 square root of x, and we can cancel this 2. Now it's actually giving you an idea that if we have this form that you have the square root, and inside the square root is having another functions, it's on the denominator, then perhaps the the function you have is from the square root. Okay. Now let our f is square root of 1 plus x squared. We will have our derivative 1 over 2 1 plus x squared and multiply with 2x, or we can write this 2x here, 2x, and cancel. I think this is the same results, right? Then by doing so, then we can write integrations of x is or equal to square root of 1 plus x squared plus c. This is possible. This is possible. For certain conditions, you can do this way. And this is correct. Okay. This is called the advanced guessing method. And it's not stated in the textbook, so I think it's important for you. So basically, you can have some trial and error for some function and check whether it has some correlation with the integral. Like this one, you can check some functions and some its derivative, and then how you can relate them to the integrations. That's the key. Another questions that interesting to analyze is integration of x e negative x squared dx. First, of course, you can deal with the u substitution. Okay, you can deal with u substitution. I think it is quite obvious. You have the x squared here, you have x here. Of course, you can cancel each other, right? If you substitute the x squared with something with other variable, right? But what I want to show you is, remember that if we have e, for example, if we have e minus with the power of negative x squared, if we want to derive this, this will turn out to be, it's just e and then multiply with the chain rule. The chain rule will be negative 2x e negative x squared, right? And when you see this structure, it's already similar to what we have here, right? And how do we make similar? We need to multiply with the whole thing here, multiply with negative half, right? So the integrations of x e negative x squared dx is negative half of e negative x squared plus c. Or if you want to use the substitutions method, you can always use that. So we will have integrations of negative 1 over 2 e with the power of u and du. So this will be still e u or e with negative x squared plus c. same answer. Okay, I think we can move on. Maybe let me write the official definition of substitutions. Okay. So substitution if u is g of x is a differentiable function whose range in interval I and f and f uh, is a continuous function on interval I, then f g of x g prime of x dx is equal to integral of f u du. You can also write u is g of x, so du is g prime x dx. Basically, this is just official statement of what we have done in the example here. Okay, now next part, I will give you more examples. Integral. Now what we have if this x with power 5 dx. Can you try for a while? Can you do this question? You can try first, and if you feel like you feel doesn't really have any clue, just let me know. Any finish? It should be a little bit complex, the result, but how we are how to solve this is actually we simply see what's the relations these two we have. Okay. How if we take this, uh, let's say we have x4 and x, and then the x. Okay. Okay. Can you see anything different? So first, if we take the u is 1 plus x squared, we have du will be 2x dx, and dx will be 1 over 2x and then du. So from this part, we can cancel this, right? Okay. And from this, we can write x squared is u minus 1, right? Okay. Now if we have x with power of 4, then we have u minus 1 squared. And we can exchange this. Okay. So this will be square root of u, and then x4 is u minus 1 squared, and then dx, so it is x, this is 1 over 2x du. So cancel. Now we have half integration square root of u, and we need to expand it the square. So u squared minus 2u minus plus 1 du. And now one by one we need to integrate. So half, this will be u with plus 2 plus half, it's 5 over 2, so u 5 over 2 minus 2u 3 over 2 plus u half, like that, and du. And integral u with power of 5 over 2, we need to plus 1, so it should be 7 over 2, so 2 over 7 u 7 over 2 minus 2 over 5, right? So 5 over 4 over 5 u 5 over 2 plus 2 over 3 u 3 over 2 and plus c. So we will have 1 over 7 2 over 5, or we exchange all with terms of u is this, right? 1 plus x squared. So 1 plus x squared, 7 over 2, minus 2 over 5, 1 plus x squared, 5 over 2, 2 over 1 over 3, sorry. And this will be the answer. So what's the idea behind this? First, you can actually rewrite the formulations into this, and then another thing that important is this one. When you have this, x squared is u minus 1. So you can do this. So it's not always just one step to use the u substitutions. Like you have u equal to some variable or element from the functions, you derive and you cancel the other one. Okay, that's the basic idea. But in more advanced questions, this might happen. So you can tweak the elements and simplify the form probably, or expand the forms probably. Okay. And by doing so, you need to focus, remove all x, change all into new variable u. Okay, that's the idea. Okay, any questions? How to know when to do this? It's basically you need some time to think. Okay. You need to have. I think it's better to have some experience. Okay, some experience. So you need to have more practice. I think. I think you will know. I think when we learn this integrations and some techniques on how to solve the integrations, later on you will see the difference when we use the difference technique. And the idea behind this substitutions is always you can think to rearrange the formulation. You can rearrange the formulations. You can maybe split the formula, split the equations. Okay. And I don't say that we can directly know how. You need to have at least some experience to see, oh, we can do substitutions here, okay, based on my personal experience. So there's no instance knowing unless you are quite experienced, having some experience on those questions. So later I will attach some questions from these substitutions, and you can check on how to solve all of those, and maybe I will just marks which part that probably you are mostly needed to increase your experience. It's like playing a game. Like you start with level 1 characters, right? Without without any equipment, no experience. And when you see the enemies, right, you kill the enemies and then you gain experience, and then you go to level 2, level 3, and then your characters becomes more powerful, right? So basically that's uh, you need experience on those. Okay. Okay, now I think one last example probably for the substitutions. If you have integral of tangent x dx. Okay, now if you have this tangent, you can always look at the tangent as sine over cosine. And from here, we can relate which part that we are going to substitute. I think it's better to substitute with this cosine, okay? Because when we have u as cosine x, we will have the u, and we can exchange, and becomes that. So we can exchange this, right? And we can write down that we have negative 1 over u. 1 over u become ln, right? And remember, whenever you integral 1 over x or 1 over u, you need to make it clear that it has absolute value here. Okay, so we will have absolute value cosine x plus c. We can also rewrite this cosine in terms of secant in order to remove the negative. So this will be negative ln 1 minus ln secant x. And thus we will have negative secant, so ln secant x plus c. If you feel confused on why we can do this, this is precisely okay. Okay, regarding the secant, the other important formula for this trigonometric is secant x dx, and then secant squared x dx. This will be tangent, right? Tangent x plus c, and then secant cube x dx. This is we learn later on, okay, when we deal with the I think chapter 7. It's the integration by parts. And some techniques for trigonometric integral. We'll learn later on. Okay. But for now, let's continue a little bit. Okay, now substitution's done. There are a few notes that perhaps we are going to use the notes in a later uh, discussion. So first is notes on integrals of symmetric functions. So suppose the functions is continuous on okay. First, if f is even. Remember the even functions from the, I think, chapter 1. So even functions is if you have negative x put inside the functions, this will be you will get back the original function. Then, so if f is even, then the integrations from negative a to a of our f of x dx, this will be twice s from 0 to a f of x dx. And then if f is odd, if f is odd, then if you put negative x, this will be becoming negative f of x. You have then this will be 0. How do we make this seems logic? How do we make this into our logic? We can make it by first is a graph. For example, you have even functions. For example, this is your function here. It's even functions, right? And you have from negative a to a. So you can see that because it's symmetric, this f of x is symmetric, then the whole area is basically twice of the 0a, right? Okay. So precisely it's correct, right? So the odd functions, well, let's say we have this as our functions. So say this is negative a, this is a. As we know, above the x-axis is positive, right? And below x-axis is negative. And because it's symmetric, then we will have 0 because positive and negative, it's becoming 0. Okay? I think by just looking at the visuals, it certainly can be observed, right? And then if we are trying to just use our proving through the formulations, we can write the integration from negative a to a. We can start by take separations between this integral. And then we switch the endpoint and take the negative part. and then let u is negative x. Okay, so du is negative dx, and by doing this, then x will becomes negative a and u become a. Now we have negative let me write here, then negative dx and negative a exchange to u. Okay, exchange to u, negative u and negative du, and then exchange 0 of a. So this will be, the negative will be cancelled. The negative cancelled with this. This will be results in 0a f negative u du. And then our f of x dx can be written as 0a f negative u du plus 0a f of x dx. Now if f even, then f negative u du or f negative u is fu, then this will be negative a f of x dx fu du plus 0a f of x dx, and the function is the same, so we can write down this is become 2 0a f of x dx. Okay. Let me put this into a smaller size. Okay, I'll make it, maybe this is also smaller. Here. Okay, so this true. Now if f odd, then this f minus u becomes minus fu. Now we have negative a f of x dx. This will be negative 0a fu du plus, and this will be results in 0. Okay. I think if you feel confused on this part, the integral part here, using the substitution, you can always look on the visuals like this. Visuals, I think, clear for the visual. This is just some proving on the symmetric functions. Okay, is it clear? So if you have an even function, then you have integral from negative a to a. You can rewrite from 0 to a and multiply by 2 for even functions. If you have odd functions, the integral will be results in 0. Okay, can I move to the next page? Okay, I think it should be okay from here, right? Or is my writing not clear? If you see uh, anything that it's not clear, let me know. Okay. Okay, I think we can move on to other sections. Okay, let me just give you some practice, before we go to the next chapter, which is chapter 6. So we are finished chapter 5, and when we finish chapter 5, then probably we need to rearrange another quiz, but I think for quiz maybe next 2 weeks, so we can have some preparation. So maybe we are having more examples for the substitutions. Let me write first. We have two integrals: secant 2x, tangent 2x, dx, and the other part is secant squared x, tangent squared x, dx. So it's a battle. Which one is easier for you to handle? Okay, let me give you a couple minutes to see the solutions for each cases. Do you think the left or right? Which one is easier? Or both difficult? Should be having slight differences, right? Which for the difficulty. What do you think? The left one or the right one that is more easy or easier? Right. Okay. True. Yeah. Because you have the squared, right? You have the squared. Because you have some connections between the tangent and the secant squared, right? You have connection with this too, and you can substitute easily, right? Okay, I think Kim already know how. How about the left one? Is there any method that makes the okay, Vicky? You also agree with Kim? Yeah, right is easy. Let me just show you the right one. You can think if you have f of x is tangent, you will have the f prime is secant squared, right? So from these connections for tangent and secant squared, we can make some substitutions and then cancel, right? And then cancel. So if we take the substitution as tangent x, then we can cancel the secant squared. So we will have we will have the integrations of u squared du, right? And the secant will be cancelled. So we will have 1 over 3 u cubed, or 1 over 3 tangent x cubed plus c. Okay, everyone agree? Or everyone still having unclear? Okay. Okay, whenever you deal with the calculus, okay, if you are having some loss in focus, on loss in thought, like maybe some process is for you is how do we get that, and then you never found the answer, then you will feel lost afterwards, and then in the future classes you will be lost, and you will be not have any connection to the courses. And that's actually the difficulty part on calculus. Whenever you have lost at least one or two parts in the middle, you will lose the connections until the end of the classes, until the end of the semester. So why most people, if you check also the other university, check YouTube, why most students they failed calculus, because they lost connections. They lost connections. So they lost thought on some process, like they're not sure why it's going to have that part, and they don't know the process, and they didn't have the logic to solve, and because of that they have they lost connections, and thus they failed the calculus. Okay. So mostly because of that, okay, they lost stuff. So I hope this calculus, okay, I can have you at least not lost connection, but we can deal with every part. Although the question seems difficult, you still have that connections. You still have that connection. And I believe, if you get your results, like for example, the last midterm, if you get a result like maybe 40, 50, for me, 40 or 50, you still have that connection. You still at least understand the questions, what the questions mean, and how to connect that with your information, okay, with your notes, with your own understanding. But if you get like maybe the below 30, below 20, I think you don't have that connection. And I believe to improve that, you need you need to catch up very soon, because I cannot go back and then doing all the things that we have done. You need to at least catch up with some other informations from other tutor. If you have tutor, please find your own tutor. You can ask the university to provide one, and also you can watch some sources from other contents, and I've shared that with you. So if you still feel lost, then if you don't have any reasons on why you should pass the course, then I will say you can take it next semester again, because I will teach the same calculus 1 next semester. I think next semester the students will be, it's not the same as last year when we have international students and mix with the honorable local Taiwanese from the honorable classes, in which you have some difficulty to adjust, right? So I think next semester will be also similar with our class in this semester. So if you fail now and probably you need to retake the calculus. Okay, so I told you from now, so you can prepare in the future. Okay. Okay, let's back to the lecture. So I think the right one clear, right? So the left one, you can start with u is 2x. So du is 2dx, or dx is half du. Okay. Now, if we look the equations, we can have secant u, tangent u, du, and then half. So we will have the integration secant x tangent x is secant, right? So this will be half secant u. U is 2x, so 2x plus c. Or again, we can do the advanced guessing. So we have secant 2x, tangent 2x. It has the same 2x, right? So if you remember, if we have secant x, or now secant 2x, if we have the first derivative, this will be 2 secant 2x tangent, secant 2x tangent 2x, and this 2 is from the chain rule. Okay, so the integral of secant 2x tangent 2x dx, we need to multiply with half, right? It's equal to half of secant 2x plus c. Okay. Okay, let me give you another one. So this one, so for 2, this will be and the second equations. Okay, which one is easier? One is easier. Left or right? Or same difficulty. Right? Okay. Are you sure, right? Yeah, let me give you a couple minutes to try this equation. let's start from the left one. For me, left one is easier because you can substitute 1 plus cos x entirely, and the u becomes negative sine x dx. So dx will be negative 1 sine over sine du. So we will have, oh, by the way, because we have this endpoint, right? Don't forget to substitute the endpoint into new variable. Okay, don't forget that. So for example, we have x is equal 0 right here, and because x is equal 0 and u is 1 plus cos x, then u is 1 plus cos 0, which is 2. And when x is pi over 2, then u is 1. So we will have a new integrations from 2 to 1. Okay, and the inside will be a negative 1 over u du. Or maybe let me write completely. To sine x over u, and then the x becomes negative sine x du. Okay, and this is simply, we can write maybe here, negative 1 over u du. 1 over u becomes ln, so negative ln u, and then from 2 to 1, so negative ln 1 minus ln 2. This will be 0, and this will be ln 2. Okay, that's for the left one. Now for the right one, we have this squared, right? With this square. So if we are going to, so first let's assume that we don't know how to solve this. So probably we are starting by doing this, and maybe take this, and then you're simply checking what it's going to be, and this will be negative sine x, and this will be resulting sine to x. And you will be confused on how we can solve these substitutions, because we will have x and 2x, or even if you want to cancel, we are canceling just sine. What about the cosine? And then if this happens, then we need to change our substitution. Maybe we take the wrong elements. The idea is we need to cancel the sign, right? What we can do is we just have cos x as our substitutions, and if we take the derivative, we can cancel easily. We can cancel the sign, right? We can cancel the sign, but we still have 1 plus u squared. So let's just write, oh, don't forget to check the x 0, then u will be, cos 0 is 1, right? And x pi over 2, and u will be 0. So we will have from 1 to 0. So integrations from 1 to 0, change all to u. So sine x 1 plus u squared, this will be negative, so this will be negative 1, 0, 1 over 1 plus u squared du. Now remember, this 1 over 1 plus u squared, if you remember the tangent inverse x, and remember, this is tangent inverse or arctangent. It's not the same as 1 over tangent x. And I'm still getting this this mistake even when you have the midterm. Okay, come on, this is not equal. Okay, so this is the arc tangent. Okay, arc tangent, not the 1 over tangent. Okay. Now, if we have tangent inverse, the derivative is 1 over 1 plus x squared, right? So when we have 1 over 1 plus u squared, this will be going to have negative tangent inverse u from 1 to 0. So we will have tangent inverse 0 minus tangent inverse 1. Tangent inverse 0 is 0. Tangent inverse 1 is pi over 4. So this will be pi over 4. Okay. Okay, any questions? Any questions from this second example? Okay, if no, then I will give you a third example. Okay, third examples. Equations x okay, which one is easier? I think it's clearly you can see, right? Which one is easier, left or right? Yeah, left. Yeah, I think I also agree. Left part is easy because you can see the x squared, right? The x squared minus 1. So you can use all x squared minus 1, derive become 2x, and we can cancel with x, right? So I think I would just start by the left one. If you substitute this with x squared minus 1, substitute with u, then we have du is 2x dx. So dx will be 1 over 2x du. I think we can write the square root of u, and then this is x over 2x du. We can cancel this, and we can rewrite this in terms of half, and then integrations u and half du. Integral, this become 2 over 3. U is x squared plus 1, x squared minus 1. This is 3 over 2. This is plus c. So this will be the result. And now the right one. How do we solve the right one? Part 1, whenever you have this structure, you have x and you have square root and you have the x minus 1. Okay. The idea, mostly, frequently, first is substitute this x minus 1. It can be x plus 1, it can be any function inside the square root. Okay? But usually it has the same degree of x. Okay? So whenever you find this example or equation, then you can start by take this. Okay. And of course, if you derive, this is du just dx. But we still have another part, which is x. But this is, I believe, similar with what we have done before. We can exchange this into x is u plus 1. Okay, very clear, right? So what's the idea behind of all of this? So basically, we are going to rewrite the square root. We rewrite the square root and exchange the square root to another element. Okay, so we will have x become u plus 1. Right? The squared x minus 1 becomes square root of u, and then this becomes du. And if we solve this one by one, this will be integral u 3 over 2 plus u half du. And this will be, u is, let me write in terms of x, so x minus 1. This is 5 over 2, 2 over 5, plus u is 2 over 3, x minus 1, 3 over 2, plus c. That will be our answer. Okay. Okay, any questions? Actually, I think we'll stop until here. Okay. We don't have much time to continue for the new chapter. So next Friday we will have a new chapter, chapter 6, the application of the integral, which relates to the area and then the volume. Because we have finished this chapter 5, so we need to prepare. There will be a quiz for chapter 5, but the quiz I think will be on next 2 weeks. Okay, I think next 2 weeks for Friday, I think. So maybe we will have on, let me check the calendars. I think next week. Friday, 13th of May. I think that will be our chapter 5 quiz. Okay, so right here, 5, 13, quiz, chapter 5. So we can have more preparations before the quiz. I can have some feedback first this Friday and next Tuesday, while we are going forward chapter 6. Okay. The quiz will be just take 1 hour of the class, so probably the first hour of the class, and then the second hour will be continue the chapter. I think for the month of May, on 520, I think we will not have any class. Okay, no class, because I have another schedule for your senior graduations, so no class. And I will change to additional video that I will prepare. So you just need to watch this video for this 20 of May. Okay. Okay, if there's no questions, then this will be the end of our lecture for today's class. And remember, if you don't really have any, oh yeah, attendance. Okay, sure. So if you don't have any really improvement, you feel not having any improvement, I'm suggesting to take on tutors. Okay, because I believe that is because you lost some thought in the middle of the courses. So please take the tutor. Okay. Do you have more quizzes before finals? Yes, I think 2 more quizzes. So chapter 5 and maybe chapter 6. Okay. Because we still have the chapter 7 and the chapter 8. But if we are not having any much time for chapter 8, maybe I'll be just focusing on chapter 7, because chapter 8 is basically just a short chapter. I can make in an additional video about the arc length. So you can calculate your percentage on the quiz midterm to prepare yourself what score you need to achieve for finals. I think we can have more discussion about the scoring on Friday, when I hopefully I can deliver the results, the midterm results to you. Okay. Okay. If there's no question, then you may leave the meeting, and this will be the end of our lecture.